This video is going to provide you with a little bit of background information on sign numbers. Now, sign numbers are another way to say integers or negative and positive numbers. Negative and positive numbers, you've been working with positive numbers your whole life. Now we're going to throw negative numbers into the mix. So if you look at a number line with 0 being, so to speak, the beginning, and anything to the right of the 0 is considered positive, and to the left of the 0 is considered negative. So one thing that you have to keep in mind is that a negative number, like for example negative 5, is actually smaller than negative 3. And the smaller symbol is less than. And the reason it's smaller is because it's farther, or further I should say, from the 0. So it's actually, the negative 3 is actually closer to 0 than the negative 5 is. And that's how you decide which number is bigger or smaller. So keep in mind that it's backwards. The bigger the number, if it's negative, the smaller it actually is because it's not as close to the 0 on the number line. Another concept that comes up quite a bit when we apply the rules for adding and subtracting, multiplying, dividing, is knowing what it means when the question refers to what's called the absolute value. So the absolute value is written like brackets, but the lines are straight. And that means when you want to take the absolute value of a number, you're looking for basically the distance from that number to 0 on a number line. So the absolute value of negative 3 is a 3, because negative 3 on a number line is 3 units from the 0. So the absolute value of a negative number will always be equal to the same number, but with a sign that's not negative, because an absolute value is merely a distance, not a sign. So in this section, we're going to learn how to multiply, divide, and add and subtract positive and negative numbers combined, with fractions, with decimals. And you are going to be required at the end of this to apply BEDMAS rules to order of operations as well. Let's start with an example. So on this page, I have 5 examples of adding some numbers. So clearly, the first one, 5 plus 2, although it's not written, there's assumed to be a positive value in front of that 5. So a positive 5 and a positive 2 is equal to a 7. You can write that as a positive 7, but we generally never write a positive sign if we don't need to. Just waste our time. Now the next example, negative 5 plus negative 2, think about that in terms of money. If you were $5 in debt, so negative 5, and you added a further debt of negative 2, you are now going to be further in debt, which means you're going to be actually $7 in debt. So the rule for adding sign numbers is as follows. If the signs are the same, a negative 5 and a negative 2, you actually add them together and keep the sign of the number. So a 5 and a 2 becomes a 7. They're both negative, so it stays negative. The previous example, 5 and 2, positive 5, positive 2, the total was 7 and the sign was positive. Where it can become a little tricky is when the signs are different. Let's look at the third one. Negative 5 plus 2. So again, go back to money. If you're in the hole $5 and you receive $2, you're no longer going to be in the hole quite as deep, but you will still be in the hole. To do the actual math of the question, when the signs are different, a negative 5 and a positive 2, or negative, you can write it like this as well, negative 5. I find this very busy. I don't like it, but it's true. Negative 5 plus a positive 2. If the signs are different, as they are here, a negative and a positive, you actually do a subtraction, because you're going to get closer to the 0 on the number line. So negative 5 plus 2 is actually going to be a difference of 3. And the sign of the answer will always be the sign of the larger physical number. So somebody if you were in debt $5 and somebody gave you $2, you're actually now only going to be in debt $3 because you're $2 closer to being at par or at zero. The next example is similar but different. Positive 5 plus a negative 2. You're going to add those. If you're going to try to add those numbers together, you're actually going to have to do a subtraction because the signs are different. So you do the subtraction, 5 and 2, you're going to get a 3 again. But this time the answer is going to be positive because the bigger number, the 5, was a positive. So when the signs are different in the last two examples, what you have to actually do is subtract the numbers and then keep the sign of the larger number. And that is explained to you in your booklet more neatly than this, but that's, an example of how it's done verbally and kind of visually. When you subtract sign numbers, the rules are different, but easy, okay? So 8 take away 2. That really is 8 take away positive 2. We all know that the answer is going to be 6. The textbooks always recommend that you take subtraction questions with integers and change them into additions. I don't like this method, but I'm going to show you the method anyway. The textbooks would suggest you take this question and make it 8, take the subtraction sign, change it to an addition, and you can do that as long as you take the opposite sign of the number in the bracket. So 8 plus a positive 2, which then becomes an addition question. A positive 8 and a positive 2 becomes a 10. There's a different way to do that question. I'm going to show you this question. I'm going to come back to this question after we do positive negative numbers and see if this will ring true in your head. But for now, change your subtractions to additions and take the opposite sign. So negative 8 plus a positive 2. Just like the question we did in the previous page, negative 8 plus a positive 2. The signs are now different, so you're going to have to do a subtraction. 8 take away 2 is going to give you a 6, and the bigger number was negative, so the number is going to remain a negative 6. And the last one, negative 8 take away 2. Negative 8, I'm going to rewrite it down here, take away 2 becomes, textbook version, negative 8 plus, the sign of the 2 is a positive, so now it has to become a negative. So a negative 8 take away a negative 2, you're in the whole $8, you're in the whole $2 more. Because the signs are the same, you're going to end up being in the whole $10 or negative 10. So the rules are, according to the textbooks, take your subtraction questions, convert them to addition, so you change to addition, and the only way you're allowed to do that in math, to make a change like that, is if you change the sign of the number you're subtracting. So you do two things, change to addition and then change the sign of the number. And that's the legal way to do it and the recommended way to do it. We'll revisit that in a minute. Multiplying and dividing sign numbers. Take, for example, negative 3 times a positive 7. Take a negative 3 times a negative 7. Take a positive 3 times a positive 7. And how about the fourth possibility? A positive 3 times a negative 7. The rules are actually very simple for multiplying and dividing. You multiply and divide as obvious, you would expect. All these answers are going to be variations of 21. If there's no sign with a number, it's always assumed to be a positive. So a negative 3 times a positive 7 is a negative 21. Because a negative times a positive, I'm going to summarize it down below, a negative times a positive will always equal a negative. The number on the end, the last example, let's kind of work sort of as backwards here. 3 times a negative 7, or a positive 3 times a negative 7, 21, but it's also going to be a negative because the rule, a positive times a negative is also equal to a negative. So basically, if the signs are different, then you're going to get a negative answer. The middle two examples on the page, if the signs are the same. So a negative 3 times a negative 7 is going to be a positive 21. You don't have to write the positive, it's always assumed to be there. And of course, a positive 3 times a positive 7, we know to be a 21. So if the signs are the same, positive times a positive is a positive, and a negative times a negative is a negative. Shit, it's a positive. So if the signs are the same, then it's going to be a positive value. So think about that. If the signs are opposite, it's a negative. If the signs are the same, it's positive. Consider this. If you have more than two numbers, I'm going to sneak a different one in here. I'll do it in a different color. Say we had negative 2 times negative 3 times negative 5. Let's follow the rules and steps. A negative 2 times a negative 3 would be a positive 6. And a positive 6 times a negative 5 would be a negative 30. So with that small little example, I want you to know another rule. If the number of negative signs in your question is even, like it was up here, 2 negatives equal a positive. If the number of negative signs in your question is odd, like a negative times a negative times a negative, your answer will always be negative. So think about that. Negatives. An odd number of negatives will give you a negative, and an even number will give you a positive. Now I want to revisit the question back here. I'll rewrite it. Eight take away negative 2. This little example we did in the previous page. This question can be rewritten in a different way with a different method. I'm going to show it to you because it might actually be easier, in my opinion, than it is. When I look at this question, 8 take away a negative 2, what I actually see is double signs. And I don't like double signs. I try to clean those up and make it one sign. Now that I know the rules that says a negative and a negative together, or a subtraction, take away a negative, I can make that into one sign if I apply the rule that a negative and a negative is a positive. And I can do this and make it 8 plus 2 and easily come down to a value of a 10. So not all subtraction questions have to be done the way that the textbook says by changing them to additions. You can, when you have double signs, use these rules of multiplying and dividing and break it down to one sign. And it might make it easier. And we'll go through these as we proceed in this section. Order operations are where you can start to recognize what you know and what you don't know. This particular example I have, you should see that there's a division question, a division portion to the question, and there's also a subtraction. Like this, I see this, and this as more priority then the subtraction in the middle. So first things first, we're going to do the division. 14 divided by negative 2. So a positive divided by a negative is going to give you negative 7. Brackets are not necessary, but I'll put them around there. The second half, 4 divided by negative 2. You can do it as 4 divided by negative 2, keep the sign, and do positive 4 divided by a negative 2 and get a negative 2. Then you're going to have to deal with this negative situation one of two ways. You can change it to an addition and do this. Negative 7 plus a positive 2. Or you can look at those two negatives together and say, hey, a negative and a negative equals a positive. And you can get the same answer. Negative 7 plus 2 is a minus 5. Or negative 7 plus a positive 2 is a negative 5. Now, someone might have looked at that question and said, how the hell do you know that that's a minus sign or a subtraction? And you can do it two ways. You could have back here done negative 4 divided by negative 2, and that would have taken you right down to a plus between those numbers. And you would have gotten the same answer because you would have had negative 7 plus 2. So remember, there's going to have to be an operation between numbers. If there's no operation, it's a multiplication, but I can clearly tell in this particular example that there has to be an operation in here because there's no bracket. Therefore, it's a subtraction. Let's do some more of these because they can be, these sort of our operations can be really quite dirty if we don't catch the tricks in the beginning. So for example, you can get double brackets. How about this one? 8 onto minus 4 plus 6, a round bracket, minus 2 plus 8, and then a square bracket. Now remember BEDMAS, brackets. This is not considered, that particular expression with these, that's not considered a bracket in BEDMAS. That's pretty much just a grouping of a negative with a 7. The B for brackets in BEDMAS refers to when you have more than one thing inside that bracket. So in this particular question, negative 2 plus 8 is in a bracket, which is also in a square bracket. So you're going to have to start, like we learned before, on the inside of the inside bracket and work your way out. So negative 2 plus 8. The signs are different. You're going to subtract. It's going to be a 6 and it's going to be a positive 6. So you're going to get a 6 inside that bracket. There's 6 outside. And you've got this minus 4 to deal with and the 8 in the front. So within this square bracket, you still have to do the multiplication next. 6 and 6 is going to give you 36. And 36 is grouped together with a minus 4. So minus 4 plus 36 is going to give you the difference, because they're opposite numbers, and it's going to be 32, and the sign will be positive because the bigger number was positive. 36 is positive. So 8 times 32, 256. Here's another order of operation question, quite lengthy. So you've got a division, you have 2 times this big bracket minus a negative 2 squared. So brackets first, obviously. The brackets first in BEDMAS means you've got to do the inside out. So the inside bracket would be 9 minus 3, which is going to be 6. 6 squared. I'm going to do that part, 6 squared. 36 plus 10 is going to give you 46 inside this square bracket. And you've got a 2 outside that bracket. And 184 divided by 2 times 46 minus, just cleaned up a little bit. The whole first bracket's done. So there's no brackets left in terms of the bracket part of BEDMAS. The next thing you would do is your exponents. So on the end we have a negative 2 squared. Remember, a negative 2 times a negative 2, or an even number of negatives, is always going to be positive. So negative 2 times negative 2 is going to be a 4. You can take away 4 or subtract 4 from that. You have 182 divided by, before you multiply. I just paused the video because I'm looking ahead at the answer key to this question I ripped off this program, and I noticed that the answer is wrong. It took me back for a second. I had to reevaluate. To do this question, you have to do the division before the multiplication. That's what BEDMAS says to do, left to right. So 184 divided by 2 is going to be 92 times 46, which we have to calculate, which is 4232 minus 4, which is going to be 4228. The answer key to the multiplication before the division, which is a no-no. Long story short, rules of BEDMAS still apply. You must go from left to right, do your brackets first, watch your signs. Now you're going to have negatives and positives, which are going to interfere, going to cause you some grief, potentially make some errors. And the biggest source of error for most students is typically going to be sign errors from now on. So don't fall into that category. We'll do 2 more. 9 minus 4 squared minus 6 squared over 4 cubed plus 7 minus 9 squared. So do the top, do the bottom, then simplify. So 9 minus 4 is 5. 5 squared minus 6 squared (4 cubed is 256) minus 7 take away 9 is negative 2 squared. So on the top, 25 take away 36. On the bottom, 256 minus negative 2 times a negative 2 is positive 4. So 25 minus 36, the signs are different. 25 take away 36, or 25 plus a negative 36 is going to give you negative 11 over I did that math wrong, didn't I? 16 times 4 is not 256, but in fact 64. Do better math. 64. 4 times 4 is 16 times 4 is, yes, that is correct, Christy, over 60. So it'll be negative 11. I feel like I made a mistake somewhere. I made a mistake when I made it a plus. It should have been a plus, which would be 68. Correct. Let's not forget that you will have to find questions from now on that have fractions and negatives together. Fractions will never die, and you will always have to know how to work with fractions. So for those of you who thought they were over, tough. Okay, so in this question, can you tell that there's a division, an addition, and a multiplication? Division, multiplication, addition. You need to do your division first. To do a division, you have to invert and multiply. So 1/2 times, flip it. The sign can stay on the top. You never put a negative on the bottom of a fraction. So 1/2 times 5/3 is going to be 5/6. Multiply the top, multiply the bottom, and because it's a positive times a negative, it's going to be a negative number. That's the product of the first. You've got to multiply that by a negative 1/6. Keep them in brackets if it helps you organize your brain. So negative 5/6 times a negative 1/6 is going to become a positive 5/36 plus a negative 1/12. Well, we have to find a common denominator. Can't add fractions without a common denominator. So it's going to be 5/36. We can make a plus and a minus. We have to make them both 36s. So 12 times 3 gives you 36. So negative 1 times 3 gives you a negative 3. There's a new fraction. Same denominator. When you add fractions, you keep the denominator and you add the numerator. So you're going to end up getting 5 plus a negative 3 is going to be a 2. And then 2/36 will reduce to 1/18. Last question just to wrap up. Try to review all the rules in one here. First of all, 16 take away 8 times 15 plus 6. Order operation question. Inside that bracket, you must be multiplying first. So you can do 16 take away 120 plus 6. And I'm going to finish that bracket down to the end. Rewrite the rest. There's something in this question that I kind of want you to see. Some people who like to do mental math more than calculator math might want to group together the positive numbers first and do 16 plus 6 and get 22. Take away 120. Maybe that is better to do in your head, I'm not sure. But that's something that is recommended, is grouping. So 22 take away 120 is going to obviously give you, if you want to do it the official way, 22 plus a negative 120. You're obviously going to be in the hole. Going to be down 98. Negative 98 divided by negative 2. And that's going to give you a positive 49. Or just 49. So when you're multiplying and dividing, it's about the signs. Negative and negative is a positive. Positive and a positive is a positive. When you are having different signs, positive times a negative is a negative. Negative has a positive is a negative. Okay, you got to have different signs to get a negative overall. When you're adding and subtracting, it's all about the bigger number and the kind of signs. So hopefully you go back and reread your notes. That'll make a little more sense. I'll do another video on exponents.